Namaskar, my dear friends. So let us talk about non-inverting amplifier simulation. So what we'll do is we'll try to design a circuit for non-inverting amplifier using opamps in NI Multisim, and we'll also see various example circuits with different input voltage and different gain. So let us first talk about what is non-inverting amplifier. So as you know, let us say we have a opamp here. So this is my positive terminal, this is my negative terminal, or non-inverting terminal and inverting terminal. Okay, so this is my input voltage, and we have R1 and R2 that is going to be used to set the gain. So what is going to happen to my output voltage? So you know already that my output voltage will be equal to 1 plus this R2, this is feedback resistor, divided by R1, this one. Okay, or sometimes people say RF, like feedback resistor. So 1 plus R2 by R1 into V in. So the minimum gain will be more than 1, that you know, right? So let us talk about that R2 by R1 is 1, like both are 1K, 1K. Then what will be the gain? So the gain will be like this 1 plus this R2 by R1, that is 1. So 2. So if my input voltage is 1 volt, what will be my output voltage? Gain into input voltage, that is 2 volt. So this is very simple. So let me give you a circuit. Let us say we have designed this particular circuit in NI Multisim, and we have opamp OPA 2277. So we have the input voltage as 1 volt. So what will be the output? Here gain is set to how much? R2 by R1, or let us say this is R5 by R4, right? So this is going to be how much? 2 by 1, that is 2. So the total output will be, V output will be 1 plus 2 by 1 into V in. Okay, so that gain is actually 3 times V in, that is 3 into 1, that is 3 volt. So as you can see, the input voltage, that is probe 1, this probe 1 is 1 volt, and output voltage, that is probe 2, this probe 2 is 3 volt. Understood? Similar to that, can we take up, like, let us say some AC signal we are going to take, which is going to be 1 kilohertz frequency and 0.1 volt peak. So what is going to happen is this particular input voltage will be amplified 3 times, because here also 2 by 1, that is 2 plus 1, 3. So gain is here also 3. Understood? So gain is 3. It means what will happen? Into V in, that is 3 V in. So wherever you can see we have 100 millivolt input, that is red signal, that is PR1. 0.1 means 100 millivolt, right? So 100 into 3, that is 300. So you can see the green signal is output, which is 300. Why don't you change the gain and see what is going to happen? So let us take another signal I am taking. I have changed the gain to 4 by 1, that is 4 plus 1. So 1 plus 4 by 1, that is gain is my 5. So my output voltage will be nothing but 5 times V in. So let us say my V in is 0.2 volt, it means 200 millivolt. So output voltage will be 2 5 ja 10, that is 1000 millivolt or 1 volt. So you can see the input voltage is 0.2 maximum, and the output voltage is output voltage is 1 volt maximum. So hope you have now a good understanding of how my non-inverting amplifier is working. Okay, so let us open my NI Multisim and we'll simulate this circuit. Okay, so what I have done is I have one opamp circuit here with R4 as resistor and R5 as resistor here, and this R6 is the like load resistor, and we have given supply voltage as 5 volt and minus 5 volt, and this is my input signal, this is DC signal. So if we run it, what is going to happen? You can see the input voltage is 1 volt and output voltage is 3 volt. Let us say I change this particular voltage to 0.1, like 100 millivolt. What will be my output? Output will be 300 millivolt. So let us run it. So you can see input is 100 millivolt, output is 300 millivolt. Let us change the gain to 5. Okay, to change the gain to 5, we have to keep the resistor 2 by resistor 1, that is 4. So 4 plus 1, it will become 5. Okay, so now you can see we have input voltage as 0.1 volt, gain is 4 by 1 that is 4 plus 1 5. So output voltage will be how much? My output voltage will be how much it is going to be? 5 times of 0.1, that is 500 millivolt. Okay, so let us run it. So you can see we have 100 millivolt as input and 500 millivolt as output. Okay, now why don't we do one thing? Instead of taking this, we'll change the source to some AC signal. So to put AC signal here, come back to place components. In this place component we have power sources. Okay, so instead of that we'll take voltage sources here, and in that we are going to take, let us say, AC voltage. So signal voltage sources, AC voltage, put it here. Now let us connect the signal quickly. So what is going to happen? We have gain as 5 times, so 5 volt. See, this is 1 volt, 1 into 5, that is 5 volt will be output. So instead of that I'll reduce this because the supply voltage itself is 5 volts. I don't want to keep that one. Okay. So if 0.2 volt is input, then output will be 5 times, that is 1 volt as in output, right? So let us run it. So you can see the input voltage is 0.2 volt maximum sinusoidal signal, and the output voltage is 0.2 into 5, that is 1 volt. Got it? We have so many pulses. If you want to reduce the number of pulse, what you can do is you can reduce the simulation time. So to do that, what do you need to do? Go to simulate, analyze and simulation. Here we are running it for 10 millisecond. Instead of that we will run it for 5 millisecond. Okay, so only 5 pulses will appear. So let us run it. Alright, so this is very nice. Now if you want to change the frequency, you want to change the gain, you can do that. So let us change the gain to 2k. Okay, so 2k means 2k by 1, that is 2 plus 1 3, so gain will be 3. So whatever the input voltage, it will be amplified 3 times. Okay, so can we do that? Let me bring out little here so that you can very easily see circuit. Okay, yes, so this is my circuit and this is my output, both put together you can see very easily. So now let us run it. Okay, so input voltage is 0.2 volt, that is 200 millivolt, and 2 3 is 6, so maximum 600 millivolt minus 600 millivolt it is coming. Now let us change the this input voltage to some pulse signal. Okay, why don't we do one thing? Instead of doing that, we will design the circuit quickly. So how to design the circuit quickly? We need to put a let me show it to you how to design this particular circuit. So what do we need for this? We need resistor, one resistor here, one more feedback resistor, one load resistor. If you want, you can give, you don't have to give this one actually. Okay, and then this is my input voltage that will be required to be amplified, and this is my sources. So if you want, you can have positive sources and negative sources both. If you have only input as positive, then you don't have to give negative sources, because op-amps are capable of running single ended supply. Okay, so let us do that. Place component, let me go to analog. So in analog we can have op-amps, and here you can write down OPA 2277. Okay. So one of them is used, I will use another one. Okay, so another one is done. Okay, so op-amp is done. Now we will have basics. Go to resistors, and resistors I will take, how many resistors we need? We need one resistor here, one more will be for feedback, and one more will be for output load. Okay, so this is done. Then we need power sources. So come back to groups, sources. Let us say we need power sources as ground, so we will need one input side ground, one more we will be needing at output side ground, and let us say which kind of source you want to feed. So let us say we will put some pulse voltage. Okay, a square wave we will put, so a square wave we are going to put. Understood? So you can see it is looking exactly almost like this circuit. Okay, now let us quickly like wire this up. So to wire up, what is going to happen? This one, and then this, and this is going to be connected like this. This is my feedback resistor, and this is my output load. Okay, we need one more ground, so I'll just select this and copy this and then paste it. Okay, so copy paste you can do very easily, not a problem. So my circuit is ready. Okay, my circuit is ready. Let us set the gain. Let's say first output load I'll put it to like 10 kilo ohm. So I don't want to drive the op-amp with very high load. So this is very low load, right? And the gain is, let us say 1k only, so it will become 2 times, like 2 volt, right? So what is going to happen? I have not changed the source voltage. Source voltage is same. I'll just bring out my probe to this location. Okay, got it? And this input signal and output signal we will be having like this. Okay, so hope you have a good understanding of how to design the circuit in NI Multisim. Got it? So this is my input voltage, this is going to be my output, and the gain will be 2 times. So if you run it, you will have twice of the output. So let us run it. So as you can see, we have 1 volt peak as input, that is red one, and the green one is 2 volts, so 2 times. If you want, you can make it, let us say 3 times. So 4 times if you want to make, what will happen? If I put 3k, so 3k plus by 1k, that is 3 plus 1, 4. So gain will be 4. So it will become 4 volt high and 4 volt low. So let us run it. You can see we have 4 volt high and 4 volt low. Input voltage is 1. So this is how you have a complete understanding of designing the circuit. Let me give you one more thing, how to rename the nets. Okay, so select it, right click it, go to properties and put it as Vin. Okay, I put it, but I did not show it. See, the preferred net name is Vin. I'll just put it as show net name. Okay, then this net name will be shown here. So this is my input voltage. Okay, similar to that, I want to put it here as V out. So go here, select the net, go to properties and put it as V out. Okay, and select show the net name. Okay, so this will be shown here. Understood? So this is how you make your circuit little better, or like the way you want, you can do that. Understood? So if you do have any questions or any understanding that is needed, you can do that. Let me give you one more changes that we can do. This is my pulse voltage source. Okay, so instead of having initial value as -1 and +1, what we can do is we can start with, let us say, 0 and go to 1.2 volt. Okay, and then my pulse width, let us say it is saying 0.5 millisecond and period is 1 millisecond. So instead of period 1 millisecond, I'll put it 2 milliseconds. So what will happen? 25% high and 75% it will be low. Okay, so let us do that. Now the gain is 4 times, so 4 into 1.2, that is 12 चौक 48, 4.8. So it will become 4.8. So you can see the input is going from 0 to 1.2 and the output is going to be 4.8. Okay, it is not going because the input supply voltage is like 5 volt, which is going to be very closer to the supply voltage. So if you want to use this, you have to increase the supply voltage to little higher. So let us say I am going to change the supply voltage to 10 volt because it should not clip, right? So and this will be, let us say, -10 volt. Now you run it because it is going very closer to 5 volt, that's the reason it is not giving you. So now if you run it, you can see it is 4.8 exactly. Understood? So this is how you are going to have. So 0 to 1.2 volt is input and 0 to 4.8 volt is output. So hope you have almost all the variations and all the requirements that is needed for non-inverting amplifier design. If you do have any questions or any understanding that is needed, you can put down your queries in the comment box and we shall be able to answer you out. Thank you.